And chapter 4.5 is the most important part of this chapter. So it's about the L'Hopital rules. Let's see the first question. To find the limit x goes to 0 4 over x minus 4 over sine x. So first thing we need to do is to combine these two terms. So it becomes x sine x, 4 sine x minus 4x. And let's check when x goes to 0 what it becomes. So because it becomes 4 times sine x at 0 is 0 minus 4 times 0 divided by 0. So it's a 0 over 0 form. So when it's a 0 over 0 form, we can use the L'Hopital rule. So if it's fx over gx, it's like 0 over 0 and limit x goes to something. But using L'Hopital rule, it's just we take the first derivative of fx and gx separately. So here my fx is 4 cosine x minus 4, and its derivative is just negative 4 sine x. And for the gx, it's sine x plus x times cosine x. So the first derivative of sine x is cosine x. For the second part, plus x times cosine x, we should use a product rule. So that's a, b. Derivative is the first derivative, second keep the same, and a keep the same, second take the derivative. So we can find the cosine x plus x times negative sine x. So now let's check it again. When x goes to 0, sine x is 0, so it's 0 over cosine 0 is 1, cosine 0 is 1, x times sine x is 0, so it becomes 0 over 2, so which is 0. For question 3, we need that x goes to infinite 1 plus 10 over x, then to the power x over 8. Because we know when x goes to infinite, this term becomes 0. So 1 plus 0 is 1. And when x goes to infinite over 8, still infinite. So this is a 1 to the infinite form. So we should use knowledge from slide 13. We let L equals to the function we are looking for. So L is equals to the limit. So that's what we are looking for. So after we let L equals to the term we are looking for, then we can take the log on both sides. So log L, that's to the left side, then log to the right side. And because the log function is continuous, so we can swap the limit and the log term. So put the limit to the outside and log inside. And log something like a log a to the power b is just b times log a. So because there is a power in the log term, so we can move it in front of log. So that's x over 8. And times log 1 plus 10 over x. And we can, because when x goes to infinite, x over 8 goes to infinite. But 1 over x over 8 will goes to 0, because 1 over infinite will goes to 0. So we just put x over 8 to the denominator. 1 over becomes 1 over x over 8. and the top part keep the same, log 1 plus 10 over x. Because when x goes to infinite, 10 over x becomes 0, and log 1 is just 0, and then it becomes 0 over 0 form. When it becomes 0 over 0 form, we can apply the L'Hopital rule. So take the derivative for the numerator and denominator separately. And after finishing taking the derivative, what's the left term is 1 over 1 plus 10 over x times 10 over 8. Now we need to check, take the limit x goes to infinite. When x goes to infinite, 10 over x goes to 0. So what's left is 1 over 1 plus 0 times 10 over 8. So that's 10 over 8. But don't forget, that's the log L. So log L becomes 10 over 8. So log L becomes 10 over 8. But what we are looking for is L. So the L, we just take an exponential on both sides, because exponential log L is just L. So take exponential, it's just an exponential 10 over 8. So that's the limit for this question. And for question 5, we need to take the limit as x goes to infinite. And in this case, when x goes to infinite, x cubic will goes to infinite, x squared goes to infinite, x also goes to infinite. So it becomes infinite minus infinite. And in this case, we can treat it as a infinite over 1. So because anything over 1 is still anything. So infinity minus infinity over 1. And in this case, we can let both the numerator and denominator to divide the highest power of x. What's the highest power of x? It's x cubic. But don't forget, outside of its cubic, there is 1 over 3. So the highest power is kind of x. So we let both numerator and denominator divided by x. For denominator divided by x, it's just 1 over x. And for numerator divided by x, we can treat it as x cubic 1 over 3. So x over x is 1. So here become negative minus 1. So we need to pay attention to this term divided by x3. After simplify it, it becomes 1 over 8 over x to the power 1 over 3. And now we need to check, let x goes to infinite. This goes to 0. So become 1 minus 0, 1 over 3 minus 1, divided by 1 over x. X go to infinite, that's 0. So it's just 1 minus 1 over 0. So it's 0 over 0 form. Because it's 0 over 0 form, we can apply the L'Hopital rule. For both numerator and denominator, take the first derivative. After taking the first derivative and simplify, it becomes this term. And now let x goes to infinite. If x goes to infinite, this term goes to 0. So it becomes 1 over 3 times 0 times 1 minus 0, negative 2 over 3 minus 8. 1 minus 0, so this is just 1. So what's left is 1 over 3 times negative 8. So it's negative 8 over 3. Okay, for question 6, to find the limit x goes to 0 positive, so x approaches 0 from the right side, x to the power 3 sine x. And we know when x goes to 0, then x just becomes 0. And how about sine x? It also becomes 0 because sine 0 is 0. So this is a 0 to the power 0 form. To find the 0 to the 0 form, first we let L equals to what we are looking for. That's the limit x to the power 3 sine x. And then take the log on both sides. And we then swap the limit and log sign because log is a continuous function. Only for the continuous function we can swap the limit and log. And because 3 to the power something, we can apply for the log property. Log a to the power b is b times log a. So we can move the power term in front of log. So that's 3 sine x log x. Okay, so for the log function, we know, you should memorize the log function like a exponential function, how it look like. For exponential function, it looks like this, but for log function, it looks like this. When x approaches to 0 from the right side, it will goes to negative infinity. So this term will goes to negative infinity. And how about sine x? We know sine 0 is 0. So, but we, I think here I did it wrong. But because this is 0 term and this is infinite term, so 1 over infinite term, it will become 0. So if 1 over log x, it will become 0. So to convert it to be 0 over 0 term, so this is 3 sine x over 1 over log x. Because when x goes to 0, 3 sine x goes to 0. And when log x goes to infinite, but 1 over log x will go to 0. So this is 0 over 0 form. For 0 over 0 form, we can use the L'Hopital rule. We can just take the first derivative of both the numerator and denominator. So sine x is cosine x. And so don't forget x goes to 0 positive. And for the numerator part, that's 1 over log x. So 1 over log x, that's log x negative 1. So that's negative 1. Log negative 2. And use a chain rule 1 over x. So this becomes negative 1 over log x squared x. Now we need to check for the numerator, it's 1. Numerator is 1. Denominator, it becomes to infinite. C3x 1. Okay. Oh, let's just follow what I wrote on the notes. Because sine x, go back here. Sine x, when x goes to 0, becomes 0, and log x, it becomes negative infinite when x approaches to 0 from the right side, so from the curve. Then we can divide 1 over sine x to the numerator part. So it becomes infinity over infinite term, because 1 over 0 becomes infinite. So for infinite to infinite form, we can also use the L'Hopital rule. Then we take the derivative for the both numerator and denominator separately. So log x is 1 over x, it's just 3 over x. While for the denominator 1 over sine x, its derivative, it's written here. So it's a sine inverse 1 first derivative. That's negative sine x, negative 2. But sine x, by use chain rule, is cosine x. So that's the numerator part. So now let's check what's the limit. So x goes to 0, it goes to infinite. Oh no. Let's simplify it. So after simplified, x goes to the denominator, and the sine x, because it's to the negative 2, so it can go to the numerator. So it becomes, after simplification, it becomes this term. Then let's take the limit x goes to 0. Sine x becomes 0. And denominator 0 times 1 becomes 0. So it's 0 over 0 form. So let's apply the L'Hopital rule again. After apply the L'Hopital rule again, we take the limit x go to 0. So it becomes negative 6 times sine x is 0, cosine x is 1, over cosine x is 1 minus 0. So it becomes 0 over 1. And that's 0 over 1, that's 0. But here, the 0 is a log L. So log L is 0, but what we need is L. So we know it's log L is equal to 0. How to find L? We take exponential on both sides. So exponential to the power 0 is 1. So the limit equals to 1.